In this problem, we are going to perform a multi-part reaction, starting with a halogenation reaction of our alkene. In the first part of this reaction, one of our bromine atoms is going to react with our double bond, and the electrons from the bond are going to flow back onto our second bromine atom, all to form a bromonium ion. Next, our newly formed bromine ion is going to attack one of the corners of our bromonium ion to free our bromine atom to form a vicinal dihalide. Now our vicinal dihalide is going to react with our sodium amide. And remember, when we have sodium amide and we have a vicinal dihalide, we are going to perform two consecutive E2 reactions. So our strong base is going to attack one of our beta hydrogens, the electrons from the bond are going to fall down onto our structure, and our bromine atom is going to leave as a good leaving group to form a double bond. And once again, our sodium amide is going to come back, and another E2 reaction is going to occur, where our strong base is going to react with that beta hydrogen, the electrons from the bond will fall back onto our structure, and our bromine atom will leave to form a triple bond. But we still have this relatively acidic hydrogen atom on our structure, and we still have more sodium amide because we have excess, so we are going to perform a proton transfer, where the electrons from our nitrogen atom are going to react with that relatively acidic hydrogen, and the electrons from the bond will flow back onto our carbon atom to form our acetylite ion. Now our acetylite ion is going to react with our epoxide. So our acetylite ion is relatively nucleophilic, and we have these electrophilic centers here on our epoxide, so we are going to perform an epoxide ring opening reaction, where our nucleophile is going to attack one of our electrophilic centers, and that is going to open up the ring. And essentially, we are going to add these two carbon atoms and our oxygen atom onto this end of our alkyne. Lastly, we are going to have water help us protonate our oxygen atom, and that is going to form this final product.